Right, hello. I thought I'd just do a feature highlight today on RowLevel Security, which just came out in the 9.5. RowLevel Security, it's a new feature in Postgres. It's something we've been doing for a long time, or used to do a while ago in databases in a manual way. More recently, though, we seem to hand that sort of level of security over to our applications teams. Maybe it's handled within frameworks, and a DBA might just create a login or a role for a couple of application users, and then it's moved over into that area. I don't know if that's the right thing to do or not. I guess each place has its own approach. I've implemented it both ways. Don't really have a preference, but I thought, hey, since it's a new feature, I might visit it and we'll have a look at what it's about and how we used to do it. So I've put a little bit of a short demo together. There's 3 windows up here just running on Ubuntu VM. I just created a little database with called RLS, and I've set an RLS role that owns the tables in these cases, and 2 or 3, well, 3 other users. There's a role called John, and I've got a role called Don, and there's also Tom that are assigned to various different roles. So I'll run through the slides. As I said, it's a new feature at 9.5, something we've been doing for a while, but we've done it manually in terms of PostgreSQL. It can reduce your exposure of your security interface by basically taking that down to the lowest level. So if you've got a lot of apps hitting the same database, we don't have to worry about one application implementing things properly and another not. So before RowLevel Security, how did we used to do it? Well, a while ago we used to generate a view. So we create an underlying table that we want to access, and then we generate a view on top of that that would essentially filter the roles by doing a join or a subquery on the table underneath, and maybe an access row column, and comparing that access level with an access level assigned to the user that was trying to access that data. So we needed to be very diligent about locking down the underlying table that we're accessing and any other views and functions that accessed it. So it's fairly involved. So I'll run through an example. Basically, here I create a permissions table. I've added a relations column so we can change the access level required for different relations, so a little bit more finer granularity. And then we need, on the table we want to access the data on, we need some sort of access level to compare that against. So I'll just log in and we'll have a look. So I've created a permission table, and we've also got a project table, and there's a couple others I'll explain in a minute. So I'll just grab some data out of the permission table. You can see what it looks like. So basically I've just created 3 different login roles that I've put into this table. We've got staff, supervisor and manager for each of 2 tables, salary and project. I've done it that way just so I've assigned, for example, supervisor has level 3 for salary, but on project it's got level 2. Just allows you to play around a little bit like that. The other table we're concerned about, or underlying table, is one called project. And you can see there I've just got 3 rows. There's a not so secret project that you need level, or an access level 1, pretty secret 2, and very secret 3. So pretty much if you're a staff member, you'll only see this row. If you're a project or a manager, and look at this table, you'll get all 3. So basically we create a predicate that restricts the rows according to the access level that we define. Now I've created a function because we've got a hierarchy of roles, so John could be a staff member and a supervisor. We need to find out the highest access level for the role memberships that he has. So I've created a little function. We can have a quick look at it, called acc level. There it is there. Basically it's just a little CTE that accesses PG roles and PG auth members, goes around, puts them all together, and then it gets the highest access level of all the roles that he's a member of. So I'll just highlight the CTE part of that function. I'll get out of there. And over here under John, I'll just get the results of that. And you can see that John's a member of staff and manager, whereas Don down here is a member of just staff. Okay, I think I've already locked down the table, so if we try and get some data back from project as John, permissions denied, so you can't see the underlying table. Now I've created a view. We'll have a quick look at the view. So the view is projects. Semicolon. And basically just gets the attributes except for the access, but it compares the access against the results of our act level, passing it the name of the relation that we want to look at. So if it's project, we get that one for the project table. So pretty straightforward. So using that means this: if it's John, I'm going to get 3 back because he's a member of manager. If it's Don, I'm going to get 1 back because he's only a member of staff, and that's the highest access level there. So select staff from projects, which is the view. You can see that John can see all 3. Whereas if we do that same query as Don, we're only get the 1 that we're allowed to see. Pretty straightforward. Now, that's all very good. I mean, this is a very simple way of doing it, but there are a lot of issues in getting around that. And I just picked this one out because I thought this was quite cool that Robert Huss highlighted in one of his blogs somewhere, where he takes advantage of the query optimizer and its flattening of queries. So he's given an example with this function called hack, takes in a parameter which you can pass a column name and just print out the value of that. The key thing is he's given this function a very, very low cost. So when the query optimizer runs, even though we're accessing an underlying view, the query gets rewritten. If I do a query like that, what we'd expect was our underlying view that checks the project access is less than or equal to the result of our function that looks at the current user and the relation that we pass into it, the result of that to go into our hack name, so it's already filtered. Well, that's not what actually happens. The optimizer rewrites the query and flattens it out. So you'd end up with something like a predicate with project access less than or equal to our filter that's part of the view, and then an and our other function. Now, because a hack name or the hack function has got such a low cost, there's a good chance of that getting executed first. So I've created the hack function. Let's execute it. And we'll pass in the name column. Oops, from the table. And you can see we're only getting our 1 row back, but that function's showing all the names. So, because it's executing it first. Now let's do an explain on the 2. Makes it a bit clearer. So if we just do our select, you can see that it's basically flattened out the query, and you can see we've got hack name and then the predicate from our view. So that's one thing. So that's where security barriers came in an earlier version of 9. Basically, you set it when you create the view, and it sets a flag that tells the optimizer not to flatten out the query. So I've created one. This other view called SB projects. It looks the same as the other view you can see there. It doesn't actually show, even though I've created it with a security barrier, it looks exactly the same as the other query. But there's the view. Basically all you have to do is add in this with security barrier, and that'll stop that flattening. So let's try it again, but this time we'll select it from SB projects, where hack name, and you can see this time we've got the one row back, but the function's only, it's not showing us those other views. So if I do it and explain this time, you can see that it hasn't flattened it out with an AND like it did previously. It's filtered by our view predicate and then pass the results of that into our next level up. So that was pretty good when that came in earlier on, but it's still a lot of work making all this stuff work. And row-level security basically makes things a lot simpler for us. There's the with check keyword there. It's the with check sort of helps maintain the integrity of it. We'll see in a minute. That's also extended on into RLS. So that's how we used to do it. Oops. So row-level security. Now you turn it on at a table level, so you can have it on particular tables. And then what that does, it controls access to the data in the table via policies. So you can create policies. If you then disable row-level security, it doesn't remove the policies. It's still there, so we can enable RLS later on, and the policies are still in place. RLS doesn't replace the normal privileges, table privileges we use now. We use them in conjunction with it, so they work together. We need to use those normal privileges to control vertical access to our tables, so column security. RLS is just at a row level. Table owners bypass it, and so do super users by default, unless we specify the force in our row security flag. And we can have a look at that. So what we'll do now, I'll demonstrate it, is I'll create a table called salary, because I've set it up in the permissions table before. So give it a ID, serial, name of text, salary, money, and then we'll insert a bit of data. So I'll give a default value, and different users. So we've got a John. We'll give him a reasonable salary since he's quite high up. And then for each of the others, so we've got a Tom, maybe a little bit less, and then we've got a Don. Okay. So there's a bit of data in there. And then what I'll do is I'll enable row-level security. Oops. So it's alt table, enable row-level security. Just got to tell it which table. Okay, so it's enabled. Now, as I said, because there's no policies, we won't be able to access the data. And I still have to implement our normal privileges, so I'm going to grant select on salary to public to start off with. And you'll see here I can select data from salary. But as the user John, I don't get anything back. So I need to create a policy to allow us to read some data. Now, I don't want him to be able to read everybody's, I just want people to read their own. So I'm going to create a policy, read own on salary. Using actually for select using I'll call the upper function on the current user equal to upper name, and that creates our policy. Now for select some data, there's John. John can see only John, and if I select some data as from the same table, so the same statement, I only see Don's salary. Okay, so now that's good. We also want to be able to update it, which we can't at the moment because we only have a select policy. So if I went through and I was Don, I thought if I was crafty, I might want to look at John's salary. Maybe I could update and rename John's name to Don, and then I would be able to select and see it. So that's where our something like that is an example where our vertical access might come in. So what we'll do is we'll create, well, let's set our vertical access too. So we'll grant update permissions on column salary only, on the table salary to public, and then should I test? No, I'll do it now. And then we'll create a new policy called update own on salary for update using same thing. Okay. Just missing policy keyword there. Okay. Now John should be able to update salary and set salary equal to, I don't know, 550,000, where name is equal to John, and that works. But if he tries to update it for Don, he can't. Okay, so and if Don tried updating salary and setting a name equal to Don, where name is equal to John, to get around the issue, he can't. So our vertical security kicks in there. So it all seems to work together quite nicely. Now what if we say we want them to update a certain amount but not too far. So let's restrict updates to $1 million. So this is where this check comes in. So we can do our alter policy, update own, and we have to specify the table we're setting it on, because you can have the same policy name on different tables, so you have to specify the table. So for update, using same thing as before, but we want with check. So this works like on security barriers, and we can just say where with salary less than $1 million. That's going to be an integer, so we need to cast it to type money. One sec. So I've altered that. I didn't need to say for update because I specified the policy name and the table. Now I can update the salary, but if I try and make it too big, it's not going to allow me to do that. Even if I do the correct person, you can see that it violates the security policy. So basically what that check does, it checks out before it actually inserts the data, it makes sure that it meets a certain level of integrity, like our check constraints basically. So it's a good way of ensuring that works. So if I bring that down a bit to maybe something a little smaller, like 550,000, then that update's fine. Okay, so that's all I really wanted to run through. The policies for row-level security, they're table specific, can be applied for the specific commands or all commands, like we saw select and update, also be for insert and delete. They can be for a specific role if we want to. There's the using, specifies the conditions of the policy, and then the check clause we can use to ensure certain integrity within the database is met before it will actually insert the row. The with check will default to using if it's not specified separately. Okay, that's pretty much all I wanted to cover. Any questions? No? All right, well thanks. That's RowLevel Security.